Let us look at an example of time value of money. In this example, we will try to find the future value of an investment. Assume that you invest in a fixed deposit for a 6-year period. The fixed deposit gives 8% interest per annum, compounded annually. If the amount invested by you today is 1000 rupees, how much will be the amount that you get after 6 years? So, the time value of money concept is based on the concept of compounding. So, these problems will appear similar to the problems that we have covered in compound interest. It is just that the way of looking at these is different. And of course, as we proceed and we go towards annuities and perpetuities, you will see how this can be used in financial planning. So for the data given to us in this example, let's try to draw a time scale. So let's say this is time period 0. This is year 1, year 2, year 3, year 4, year 5, and year 6. So this 1 represents the end of year 1, 2 represents the end of year 2, and so on. Now the initial investment is 1000 rupees. And we have to find out how much will be the amount at the end of 6 years. Now the interest is given to us as 8% per annum, and the amount is being compounded annually. So what that means is that at the end of each year, the principal at the beginning of that year is added to the interest accrued during that year, and then that amount becomes the principal for the next year. So for the first year, the principal is 1000 rupees and 8% is being calculated on 1000 rupees. At the end of year 1, the principal will be the original principal, that is 1000, plus the interest gained during the first year. Let's say this is P1. Now again, you will accrue 8% interest for the second year. So at the end of second year, the principal for the third year will become the principal at the beginning of the second year, that is P1, plus the interest accrued during the second year, which is I2. Now again for the third year, the interest accrued will be 8%. Now this 8% will be on P2. So at the end of the third year, the principal for the fourth year becomes P2 plus the interest accrued during third year, which is I3, and so on. Now generally the formula for calculating the amount at the end of a tenure using compound interest is A is equal to P into 1 plus R by 100 to the power n. Now A is the amount that you will receive at the end of the tenure. P is the principal that you have invested today. R is the rate of interest per compounding period. Now this concept is important. So rate of interest per compounding period, and n is the number of compounding periods. So this concept will become very important as we go towards semi-annual compounding, quarterly compounding, and so on. Now, based on the same concept, for time value of money, we call this amount as the future value, so FV. So future value is equal to P, which is the investment today, and this is known as the present value, multiplied by 1 plus R. Now a lot of times people call this I, which is the interest rate. I will continue to call it R, divide by 100 to the power n, and n is the same thing, number of compounding periods. Now a lot of books mention this as FV is equal to PV into 1 plus I to the power n. Here I is nothing but rate divided by 100. So if it is 5%, R is 5%, then they use I as 5 divided by 100, which is 0.05. So it's the same thing, same concept. So now let's plug in the values that we have been given in this example. So we have to find the future value. So FV is equal to, present value is 1000 rupees, 1 plus R. Now R is 8% per annum, and N is also based on an annual basis. So we'll continue to use 8 as the rate, divided by 100. N here is 6. So this is equal to 1000 into 1 plus 8 by 100. So this becomes 1 plus 0.08 to the power 6. So FV is equal to 1000 into 1.08 to the power 6. Let me pull my calculator here. So 1.08 and x to the power y, 6, multiplied by 1000. So this is 1586.87. So future value is equal to 1586.87 rupees. So basically at the end of 6 years, the amount of money you are going to receive is 1586.87 rupees. So the present value is 1000 rupees, future value is 1586.87 rupees. Now let's take the case where instead of compounding the interest annually, we compound it semi-annually. So basically this P1 is equal to P plus I1. This calculation is happening after 6 months instead of after 12 months. So basically our periods now become 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So these are the periods now. So let us look at this calculation now. So the formula for future value is present value into 1 plus r by 100 to the power n. Now if we are considering the compounding to happen semi-annually, basically we just saw that we have 12 periods, so n becomes 12. Now r is the rate of interest per compounding period. Now here the compounding period is 6 months, but we have been given the rate of interest per annum, which is 12 months. Now for 12 months the rate of interest is 8%. So for 6 months, how much? Cross multiplication. So let's say this is x. So 12x is equal to 6 8s are 48. X is equal to 48 by 12, which is equal to 4. So the rate of interest for 6-month period is 4%. So now let's plug in the values. So future value is equal to, present value is 1000 into 1 plus 4 by 100 to the power 12. So 1000 into 1 plus 0.04 to the power 12. So 1000 into 1.04 to the power 12. Let me pull my calculator. So 1.04 to the power 12 multiplied by 1000. So future value is equal to 1601.03 rupees. So when we were compounding annually, our future value was expected to be 1586.87 rupees, whereas if we compound semi-annually, the future value of our investment will be 1601.03 rupees. So if you are given an option to compound annually or semi-annually with the same interest rate, you should choose compounding semi-annually because your future value of the investment will be higher. And we all already know why it is higher, is because instead of accruing the interest annually and then calculating the next year's interest on that previous year's interest, we are doing that semi-annually. So after the first 6 months, basically you are calculating how much is the principal and the interest during the first 6 months, and for the next 6 months you are getting the interest on the interest that you accrued for the first 6 months. So when you add all that up, basically your future value increases.